Hello, guys. Here is a question, right? So you will get in almost every system design interview at some point, designing a short URL, URL shortener, or tiny URL. Sometimes it's been said tiny URLs. Sounds almost so simple, right? You paste a long URL and then you get a short URL back, right? But let me ask you this. What happens when you have like 100 million people clicking that short URL at the same time because someone with I don't know with 1,000 million followers just tweeted something, right? And then suddenly we might need to do some capacity calculations to see how we want to design this system. So imagine you have 100 million short URLs per day, which you have to support. And then imagine if I have to calculate it per second. So I'm dividing with the seconds we have per day, which is 86400 seconds, which comes around 1200 or 1160 writes per second. So these many writes we have to support. And then I think the writes is fine. The biggest challenge is the reads, right? So if one of the person tweeted this and 100 people have clicked that URL, then you will have more writes, which means 116,000 reads per second, which we have to support. And imagine the storage, right? So if the one shortened URL takes 500 bytes, and we can ask interviewer how many years do we want to store this information? So let's imagine 5 years. So imagine 100 million URLs, which we have to generate per day into 5 years, which is basically 182 billion links, which you have to store. And each of them takes 500 bytes, which comes up to 90 terabytes. Um, then then how do you store this, right? So I think the main algorithm here is we have different approaches, right? So first one is hashing a URL. So you just get the URL, you hash it, and then you can use MD5 for 7 characters, which will return you back the short URL. The problem with that, you will face collisions because you could have the same URL could be generating the same hash and then the same 7 character prefix, and collision can happen, which will end up you will have just given someone the wrong destination in that case, which is an issue, right? So other approach is how about auto incrementing a counter, right? And converting to base 62 because base 62 is unique, simple, but the problem is sequential, right? So people can iterate through your IDs. For example, 1000 becomes Q1 in base 62 and 1001 becomes maybe QJ, and then people can hit the sequence and then they can get your actual long URL, which is bad, right? So the clean solution is basically use a distributed ID generator. I think Twitter created this. They call it Twitter Snowflake ID generator, which is basically unique and it's non-sequential, and it's also it's no longer a single point of failure because it's on the distributed system. So that's also good about this. Now, if we talk about databases, right? So we are not doing basically heavy kind of joins and stuff here. So short URL maps to long URL, right? So there's no joins, there's no aggregations, it's just a key value pair, right? So do you need relational database? I don't think so, because key value store like Cassandra or DynamoDB is much better fit. They're horizontally scalable, fast reads, built for with high throughput, right? Because we have so many reads here, so that's the database we can go with. Then about caching, right? That's another piece because you have so many reads here. You can use some sort of a cache like Redis or something else, but which can help you saving some database calls, a lot of database calls, right? So there's always your shortener traffic follows the Pareto principle hard, right? So which is like 20% of your links drives 80% of your traffic, right? So basically, if we look at, you have a client, you have a load balancer, then you have different app servers, then you can chime in some Redis here, right? And then you have a Cassandra, which is your database. You can ask interviewer if they want analytics, but you can have a async process sending it to analytics. You can have a Kafka to to might be expecting is a small detail about 301 and 302, right? So 301, if you're not sure, it's basically a permanent redirect, right? So browser caches it and never asks your server again, which sounds good for performance, right? But whereas 302, which basically browser doesn't cache it and the server redirects it, which is helpful. Why? Because let's say you're doing analytics and you're doing counts. You want to see who clicked and how many times they clicked it, right? So if you use 301, you will not get that information. If user clicked a second time, the browser will return back the long URL and rejects them. So 302 is better approach in that it will hit the server, but you're getting a good trade-off with the analytics here. So that's all. I think that's system design, reasoning through trade-offs out loud, not memorizing an architecture. And that's all. Next up, I'm thinking to have a video around designing a tweeter. So things are about to get a lot more interesting. Stay tuned.